Thanks to Douglas Adams, we're going to do a session on so long, and thanks for all the fish. We're going to be looking at how we can protect our email domains and our users from phish, inbound, and how we can help our partners and our customers, when we send emails to them, help them from our domains and our email addresses being phished. So it's a two-way process. We're going to protect us, and we're going to protect others. My name is Brian Reed. I'm an Exchange Microsoft Certified Master and Office 365 MVP, and I live in Oxford in the United Kingdom, where I work for NB Consult, a consultancy company that specializes in this sort of thing. We're going to do some terminology to start with. Okay? 6 things that are important to be aware of. Okay? Phish, fraudulent attempts to obtain sensitive information. So we're more than spam. Spam is just annoying, gets in the way, fills up our inbox, fills up our junk mail quarantines, etc. This has a particular purpose. It has a particular aim to get money out of us, or to get confidential information out of us or our users. Spoofing. We make email messages are made that appear to come from someone, but actually come from someone else. Okay? So the sender address typically is forged. It's not from them, but it looks like it's from them. And impersonation is spoofing with a specific intent. So I can spoof any email address, and we'll talk more about that in a moment. But impersonation is, I know something about your business. I know that your business does, let's say, deals with such and such a company, or I know anything about you. And there's loads and loads of available information online about what you do and who you are, etc., etc. So I find that out, and I send an email to you, or the malicious actor rather than me. I'm the good guy. And they impersonate someone you're expecting to receive an email from. Okay? And you fall into the trap of thinking it's from them and doing what they ask you to do. And then we've got 3 other terms: sender policy framework, domain keys identified mail, and domain message authentication reporting and conformance. And for those of you in the room, you can see that I'm reading that last one off the screen. SPF, DKIM, and DMARC. We don't tend to refer to them by their full names. Okay? And we'll go into detail on what they are, but they're techniques that enable us to authenticate or prove where our email comes from, so that the receivers of our email can say with a degree of trust and certainty that email did come from mbconsult.co in my case, or Microsoft.com in the case of our hosts, etc., and so on. Okay? So we can use those technologies to help us do that. What's the issue, though? Well, the issue at phish obviously is financial, but what's the issue from the IT pro perspective? Well, from the IT pro perspective, these technologies to protect against phishing, some of them have been around 15 years. These are not new technologies. This is not a talk that is brand new to this conference. I've done a smaller version of this last year. There are many resources for this available on the internet. But the issue behind this is SMTP has always, since it was created, has always been default anonymous. I can create any sender address and send an email. I've got to get the right recipient address for it to get to the intended recipient. But the sender, I can make up a sender address. You know, when you sign up for an Outlook.com address or a Gmail address, you can really put any name in there. Okay? Okay, it comes from Gmail or Outlook. But equally, if I bring up a Telnet client, port 25, I can send an email, I can type whatever I like. Okay? It is by default anonymous. I don't have to prove who I am when I'm sending you an email. It's really down to you to decide if I give you enough proof to accept that email, to act upon that email. Okay? That has advantages. I've got it in quotes there, but proper use of this changing the sender or not proving who the sender is. That can be outsourced marketing emails. I can give another company the responsibility to send something on my behalf. Okay? We might want to do that. As I say, marketing is one use of that. I don't want to do all the marketing myself. I want to use someone else to do all the tracking and analytics that goes behind that. But I might want the email to come from me or my organization. So it's a legitimate email, as far as I'm concerned, but do you know that? Are you going to receive it from me and accept it as authenticated? And mailing lists is another good example of. There's much less use of mailing lists nowadays than there were many years ago, but still, I receive an email from a mailing list. I reply to the email from the mailing list. I don't send the email to all the members of the list. My email goes back to the list organizers, and the list organizers send it to all the members of the list, but they send it as if it was me who sent it. Okay? And there's problems there because I might be using, let's say, my work email address to a mailing list that is personal use or whatever. The mailing list is sending it as if it's come from my company, or the mailing list sends it as if it's coming from Outlook.com or whatever. Okay? They're legitimate uses of email. They make use of the fact that SMTP is default anonymous. And then the authentication pieces that we can do, how we can protect our domain, how we can protect our recipient sender addresses. Okay? It's difficult to do well. So SPF, DMARC, DKIM, the three terms we had earlier, they're difficult to implement well, and the perceived difficulty of that, because actually they're not that difficult really, but the perceived difficulty of that is that, well, if I implement them and I implement them wrong, the people that my organization send email to will not be able to. My emails will bounce, my emails will be blocked, my emails will be dropped. Okay? And so there's a perceived risk that's arguably greater than the problem that we're trying to fix, but it should be the other way around. The problem that we're trying to fix to protect our domain, to protect our intellectual property of our domain and our senders is of greater risk if we do nothing. Indeed, Microsoft, if you don't authenticate your email and you try and send email into Microsoft hardware, Microsoft resources, so Office 365, if you don't authenticate your email, Microsoft are much more likely, indeed are going to, mark your mail as junk. If you are, it's a bit strong to say can't be bothered to authenticate your email, but if you haven't put the relatively simple tech in place to authenticate your email, then Microsoft are going to say, we can't prove that. Now, they have machine learning and a whole bunch of other stuff to help get over that massive barrier of phish is a big problem. Microsoft want to stop it. But if they stop it, as in they block all emails that are unauthenticated, there'll be a massive other outcry along the lines of, Microsoft are blocking all my email. Well, if you do this, and then Microsoft decide that phish is such a problem, business compromise email is such a problem, they're just going to go, if you don't authenticate, you're not getting in. Hard stop. And that's the sort of problem we were talking about, that is the sort of level of fix that needs to be looked at. Well, if you implement authentication technologies on your domain, you will get past the barriers that do get put up. How much of a problem is it for people authenticating email? Well, Microsoft published this research about 6 months ago, so this is March, and 9% of Fortune 500 companies did a level of email authentication where they tell you that if it doesn't come from them, if it can't prove that the email came from that Fortune 500 company, you were to throw that email away. Okay? So it's the two blues in the pie chart. Okay? So 6% of Fortune 500 companies had a policy on their DMARC, a DMARC policy of reject, and we'll talk about what that means in a few moments. 3% of Fortune 500 companies had a policy of quarantine. Everybody else, the 31% that had no policy, or the 60% that had no DMARC record at all, they are all vulnerable to having their domain and their recipient address, effectively them sending, their sender addresses being spoofed. You don't want to be in that category as well. And as I say, what we're going to say today, it's hard, it has risk, but it can be done well, and it's not that hard to really do if you spend just a little bit of time at it. Okay. So, what are they? Well, they're DNS records in the simplest way of looking at them. Okay? They're SPF, DKIM, and DMARC. SPF is a DNS record. It's a text record. You put it in the root of the domain. You create one of them. You can tell here some of the issues I've seen when I've gone to customers. Multiple text records for SPF is incorrect. Single record. It will start with V equals SPF1, and it will end with a qualifier, in this case the minus sign, the hyphen, and all. And in between the start and the end, and it's a string of data, in between the start and the end, you basically list all the sources where your email can come from. Now, there's limits to the amount that you can do, the length of the record, and so on. So there's a few problems there, but without that level of detail for this talk, For example, here I've got a couple of IP addresses that my email is going to come from. So maybe I have a marketing company and they tell me the IP address they send from. So I might go IP4 : and the IP address, or a range of IP addresses which I don't have in that list there. So I might have like /24 or something like that. And it's IP4, it's not IPv4. It's a colon, it's not a space. Plenty of types of mistakes that people make in putting these together that are relatively simple. There are tools out there for building these records for us. And then if you outsource your email sending, or another company does some email sending for you, you can include their SPF record in your SPF record. So include spf.protection.outlook.com says, I use Office 365, they send email on my behalf, they're my email sender effectively, and I'd like to include their SPF record in mine, so I don't have to keep adding their IP addresses when they change them, and I may not know that they've changed them. Okay? Now, if we were to look in that SPF record, we might find a different qualifier at the end. That doesn't matter. The qualifier, the only qualifier that counts, is the qualifier in our record. And in this case, that says -all, and I'm saying that is it. There are no more senders for my domain. If you get an email from a different location, then you should consider it risky. Of course, this is where the risk to the company comes in if I forget to update this record. Or the marketing department will blame them. Some other department in the company decides to spin out a marketing service somewhere and doesn't tell IT. And then they come complaining to IT going, all my marketing emails being junked. It's like, yes, we know. You should be on this list. You need to have the domain authorized by the person who's in charge of the SPF record. SPF, though, has a big problem. Its biggest problem is you have to send directly to the recipient. If you bounce the email through some other service, so for example, I send an email to a user at home, okay, and they're using, let's say, isp.net, some arbitrary ISP, and they decided years ago that that was the email address they got when they have their home broadband, but then they decided they were going to use outlook.com, and they decided to forward all their email from isp.net to outlook.com, but the record I have for them is their address at isp.net. So I send them an email at isp.net, it goes into the isp.net's infrastructure and gets forwarded to the outlook.com address that they've configured on their mail. Outlook.com sees an email coming from my domain, but from the infrastructure belonging to isp.net. isp.net is not on that list. They are not a sender of my domain, and therefore outlook.com quite happily will junk or throw away that email. Okay? So SPF doesn't survive forwarding. DKIM's our next technology. Again, it's a DNS record. Okay? Again, there's technology behind this, but it's a selection of headers in the email message and the message body, and the sending server takes those headers and the body, encrypts them, public-private key type encryption, encrypts them, the server's got the private key, and adds another header to the message, which is that encrypted blob of data. That's it simplified. The email arrives at the recipient, and the recipient server sees there's a DKIM header. The recipient environment does the reverse, takes the same headers, takes the message body, takes the public key, now not the private key because they don't have the private key, takes the public key, and they get the public key from DNS. And it's a very, very long string. That's why I've got the ellipsis in the middle of the example on the board. You know, it's much, much longer than that. They read the public key from the DKIM record, and they reverse the encryption that you've just done. And they also take those same headers, and they compare. In other words, if the header that says this is what the message should look like matches the same technology, the same encryption that I do when I receive it, if they match, then it must have come from the person who owns that domain, because the person who owns that domain is the only person who can update DNS. Well, that's how the theory goes, anyway. It is vital that you manage your DNS well, and we could have a whole discussion on that as well, couldn't we? Okay. This will survive forwarding as long as the forwarding organization doesn't modify the message. Okay. So if you bounce it through a system that rewraps the message or adds their own footers and headers and so on to the body, that will fail DKIM. But if it doesn't get modified as it goes through the forwarding system, so we take our example, it goes to isp.net and isp.net sends it to outlook.com. If ISP.NET does not modify the message, then Outlook.com will see the email came from me because they can reverse the DKIM and know that it came from me. So it's good to implement SPF and DKIM because they have two different benefits to them. But the problem with both of them is it doesn't say what to do if it fails. There's nothing in SPF or DKIM that says, if the message fails DKIM, or if the message fails SPF, I would like you to quarantine it, or I'd like you to throw that message away. And that's what DMARC is. DMARC allows me to tell the recipient what I want to do with those emails that fail, and also allows me to do some reporting. The DMARC record, the important piece here, is the policy, P equals in the screen. So P equals reject. So it can be P equals none, P equals quarantine, or P equals reject. And we saw from the pie chart earlier that most companies are a none or don't even have a DMARC record. Okay? P equals none, you can use it to do reporting, but it's not going to tell your recipients that email is bad, please throw it away. You want to get to P equals reject. That's your aim. Okay? And so you're telling. And you can put some email addresses into the rest of it, and you can get some reports, and we'll have a look at some of that reporting stuff later on. Okay. Just noticed there we go. I've not put my computer into sleep mode. It's gone to sleep on me there. I need that in a minute. All right. Okay. So it sounds hard. Are there easier ways? Well, machine learning is the answer to everything, as we've heard this week. And Microsoft have their knowledge of email coming into Outlook.com and Office 365. It's all the same infrastructure. And they have knowledge of email coming in, and they know bad senders, and they know good senders. Okay? And so they can stamp on an email what's called composite authentication, or the comp auth header. Okay? For the last while, that's been on ATP customers, but that's coming to everybody. Okay? If you're just an EOP customer, not an ATP customer, you should be EOP and ATP to give you the best. But if you're just an EOP customer, then the comp auth information will come to you. Okay? But it's basically Microsoft's understanding of email senders across what they call their security graph across the internet. Okay? So, for example, if they know that your domain regularly comes from a bunch of IP addresses, but you haven't published SPF and DKIM and DMARC, they might make a decision that is what they think you would do for SPF, DKIM, and DMARC if you did it. They basically go, oh, well, that domain sends from there. And then occasionally, it gets that domain from over there on the internet. Well, if it regularly comes from over here on the internet, and now it came from over there on the internet, that's probably bad. They're making that decision on your behalf. They may not be right. You might have moved provider. And now your emails legitimately are coming from here, and Microsoft start throwing them away as junk until enough come from there that they decide, well, and less come from over here, that they decide, well, actually, that's the good place to be. If you published your DKIM, DMARC, and so on records, then they would know that you were using this new provider, and that is correct. They are making assumptions, and assumptions can always go wrong. But that's the idea behind it. Okay. There's anti-phish policies. That was ATP only, and next week is beginning to roll out to all EOP customers. And we'll have a look at the default anti-phish policy. With Advanced Threat Protection, Office 365 Advanced Threat Protection, you're going to get a default anti-phish policy that does anti-impersonation and anti-spoofing techniques. If you're not an ATP customer from next week, you're going to get the anti-spoof. You don't get the anti-impersonation piece. You just get the anti-spoof piece. But we'll have a look at that in the user interface. Okay? And you can create additional policies, and we'll go through that in the user interface as well. It's all in the Security and Compliance Center. And it can also be done. By PowerShell. So let's take a look at a demo, and let's pop over to my other browser. Okay. So on here, I've got Security and Compliance Center. I've opened up Threat Management just to save the time of this loading and the 45 minutes that I've got, and I've gone to Policy, and I can go in and click on, in this case, ATP anti-phishing. I've got an ATP license, so it's ATP anti-phishing. It'll be anti-phishing just, it won't have ATP on it if you don't have an ATP license when this rolls out shortly. Okay. I have a default policy, and I'll have a look at that in a moment. So I can click on the default policy, and everyone's going to get that default policy. Okay? And then I can go and create a custom policy, and we'll have a look at that as well. Let's have a brief look at the default policy. There's not a massive amount of space on these screens, so you can see from the back. But basically, I've got on the left impersonation and spoof. Like, put those two on the screen. So if you're an EOP-only customer, you'll get the spoof bit of this. If you're an ATP customer, you'll get both bits. Okay. And when you're setting all this up, by default, the default policy, there's no applies to section here. The default policy applies to everybody. Okay. If you want to create a policy that you want to apply to a subset of your organization, that's when you create additional policies. But the default policy applies to everybody. Okay. There's a whole bunch of things turned on in there. What I'm going to do, I'm going to close that one. I'm just going to have a look at the policy that I created. It's got some more stuff in it. Okay. So here's one I made instead. Okay. So we have a policy setting, which has a name. We say who it's applied to. So in this case, it's applied to all the domains that the company uses. Okay. I could choose I could apply it to certain people. So I could create a policy that applies to the finance officers, the finance department, the chief executives, the CX, the VIPs of the organization. But of course, everybody's important in your organization. I could choose who to apply it to. Okay. And then I could say, for example, if it's the finance department, I could have a stronger policy over everybody else because it's the finance people are more likely to get emails saying, please send money to. And so I might want to do extra levels of checks on emails into the finance department. In terms of impersonation, let's edit that and see how much we can see. And if I can't see a lot on the screen, I'll go back and change it. Okay. So in this example, I've got users to protect. I've got myself in there. I've got the finance department, and I've got other directors of the company listed. Okay. And for interest later, I've got Tim listed. We need to remember Tim's name, and we'll come back to him in a bit. Okay. I can say what domains I'd like to protect against. It's automatically going to protect my domain, and I can say custom domains like partners. Now, earlier we said this was applied to people who have this domain. What this is setting is saying, if an email comes in that looks like it comes from a domain that I own, but it isn't a domain that I own, or it comes from outside and it is a domain that I own, where in reality those domains should come from Office 365 or my SPF record to help. Okay? But if it looks like it's from me, but it isn't from me, then that's what I'm protecting against. Okay? And in this particular example, I've got added 2 extra domains that I don't own, but are similar in name to, and I might want to say, for example, let's say someone gains control of one of those 2 custom domains at the bottom. They could use them to spoof and phish my organization because they look like domains my organization might own, but my organization doesn't own. Okay? And so I'm adding extra protection to those. Okay? But it will take variations on my domain names without me actually adding those domain names anyway. Okay? Then what am I going to do? In my case, I'm just moving it all to the user's junk mail folder. But arguably, that should be a lot higher. It should go to quarantine or be rejected. And I've got options in here to do things like forward to an additional email address, BCC an additional email address. So I can turn this on and have the high level of protection, but initially not impact the user. Okay? So I forward it to a shared mailbox or something. I look in the shared mailbox at everything that Microsoft decides is impersonation or spoof. And maybe even within a couple of days, I might be saying, right, quarantine. I don't really want that email going to the users. I want it going somewhere else. Okay. So I say what domains I want to protect against. I say what users I want to protect against. So for example, I've put my name on that list. If an email was to come from outside and it said Brian Reed on it, okay, the phishing system will say, the protection system will say, well, that is a name that's on this list. An email from outside that's claiming to be from Brian Reed. We're protecting against emails from Brian Reed. And so it would mark it as possibly more likely to be junk mail. Okay? And I see this all the time as a consultant. I'll go to another customer, I'll set up some mailboxes, I'll do some tests for an Office 365 migration, and those test mailboxes probably have my name on them. And then I'll email myself to make sure that email flow is working. And I know I have to go and look in junk mail for it. Because it looks like a phish from me. In that case, it really is me sending that email. Okay, but if I was a chief executive of a very large organization and I had a mailbox in Gmail, for example, and I decided one day that I was going to email the finance department from my Gmail account and go, I need you to move this money. Well, I really, really shouldn't be doing that. Okay? I should be using my corporate email to make those asks and questions. This would block that. So if you have your chief executive and he happens to use Gmail all the time to send email in, or another provider, it doesn't have to be Gmail, okay? This sort of thing will block that. Okay? So you need to turn this on, but you need to turn this on with care. There are scenarios where you might block legitimate email, so be aware of what it's actually going to do. We also have mailbox intelligence, which is excellent. With my mailbox in the cloud, and soon with my mailbox on-premise routing through EOP, mailbox intelligence looks at who I email and the relationship between me and the people I email. And the idea behind this is, if I send an email to someone and we have an email communication for a while, and then I get an email that looks like it's from that person but actually isn't that person, the mailbox intelligence person will know that it isn't them. It isn't someone that I often communicate with. It might be an email. It might say, this is the first time you've received an email from this person. What do you want to do? Is it really them? Or this is an email that looks like you received it from someone that you normally communicate with, but it isn't that person. Okay? So I could, someone, a malicious actor, go and look on, pick your favorite social media engine, see what my business is doing, look on my company website and find my partners, and then start sending email from those places into my organization, trying to fish details out of me. Okay? I would get an email with a banner embedded in the message. And the banner says, this is the first time you've received an email from them. And you're like, no, I communicate with them all the time. That's because it's not them. It's someone else. It just looks like them. Okay? And so mailbox intelligence is what allows Office 365 to do that. Okay? There was a question in the threat intelligence session earlier this week, was, should I turn this off? Is there a scenario where I should turn this off? And Microsoft's answer to that was no. If you turn it off, they're still going to do the mailbox intelligence work in the background. They're still going to work out the relationships that you send and receive email for. They're just not going to apply that to the protection, and it's the protection you want. Okay. Trusted senders and domains. I can basically whitelist some stuff if I want to. I can review my steps, and I'm going to cancel at that point. Okay. So I've got this policy in place. Okay. And that one applies to, in this case, because this one was actually created, although it says September there, it was actually created before the default policy turned up. Okay. So I could just take the default policy and modify it to suit that in this particular example. But I could create maybe another policy that applies to finance, I could create another policy that applies to the executives, et cetera, with greater levels of protection. All right. So that's the anti-phishing stuff. Okay. We can also then go and have a look and see what that's like in terms of reporting and insights. Okay. So to save a bit of time again, I've opened up another tab, and all I've done here is gone to, scroll down to the bottom, all I've done here is gone to Reports Dashboard. Okay. And one of these boxes, this particular one here, it says spoof domains that failed authentication. That one takes a minute or so to populate. So I opened the window in advance. Okay. I've got lots and lots of insights into my phish here. Okay. So for example, let's move that one up so we can see it better. Spoof domains that failed authentication over the past 30 days. Into my organization, 139 pairs of domain setups, and we'll see what they are in a moment, failed authentication, and Microsoft were highly suspicious about them. 19 were medium, and 700 plus were okay. Now, a domain pair is where the sending infrastructure is one organization, and the domain it claimed to come from is another. So take the example of, we had one earlier, I sent an email, my organization sent an email to isp.net, and that got forwarded to the recipient. Okay? That would be a domain pair. The email came from my domain, but came from the infrastructure of isp.net. So that's the pairing. And Microsoft make a determination based on their knowledge of the internet as to whether that's suspicious or okay. I can go into this list and mark some things as safe. So for example, if I see an email from my domain and from a marketing company, I might go, well, I use that marketing company. That's a legitimate pairing. I'm going to allow that. I'm going to mark that pairing as safe. And I can do that in the list. I can do that from PowerShell as well. Okay? But that's just the report that we can look at to get that. Okay? So I can mark stuff as okay. I can also have a look at users that have been impersonated. I've got no domains that have been impersonated, but in the last 7 days, 3 of my users have had impersonation applied to them. So let's go and have a look at what's going on there. Who's having email sent as if it's from them into my organization? Okay. And it's going to take a few seconds. I think I've got it open on another tab just to save a bit of time. I do. Okay. So there's the 3 senders. If you're in the room and you belong to these companies, here's your job for next week to fix. But let's have a look. And the one I'm particularly looking at is this top one. Okay. All right. So this is an organization, a legitimate and real organization, but they do timesheet systems. Okay. And we can have a look at this list, and we'll see that in the last 7 days, emails have come in to various people. Warren's one of my colleagues. He might be in the room. Okay. And an email says, incomplete timesheet, blah, blah, blah. Please fill it in. But it was delivered to his junk mail. Okay. Now, this is a legitimate business function. It's timesheets. But it's not going to where I want it to go. I want these reports to go into the recipient's inbox. Why did they not go into the recipient's inbox? Okay. So I can go off and I can click on, there we go, Explorer. And we can expand the Threat Explorer and get some more information about those emails and why they might be going into a particular phish location or into the junk mail. So we open up the Threat Management Explorer. It's already filled in the filter for me, saying who the sender is. I can see that there's 9 emails on the 24th of the month. And I scroll down, and I can click any one of these. This is the one to Warren again. And click any one of these, and I can get some information about that particular email. So I now see here, for example, that the sender's name of that message is Timothy Stockwell via the application that's sending the junk mail. They are, in effect, spoofing the chief executive of the company. They're not intending to do that, but that's effectively what they're doing. They're sending an email claiming to be from Tim, but it's not from Tim. It's from them. Now, they would have a very simple fix. They just have to say sender name equals the company, or sender name equals something else. Because I'm protecting against emails from the outside coming in from the name of the executives, because that's a classic phish example. Here's a legitimate email that falls foul of that protection. And I can use the tools, once I turn this on, to then go and say, okay, well, I really do want that email to get in. And so if I go up to the top, I can add that to the allowed to impersonate list with one click. Okay? I intentionally didn't click that before because I wanted to demo it here. And the next time I do this demo, I'm sure there'll be somebody else I can pick on. Sorry, click time for picking on you. Okay? But it's really easy for me to go into a real system and take real data because email is so easy to impersonate. We talked about that right at the start. Email is so easy to impersonate that it is being misused. Here, misuse is probably a strong word, but it's being used for a business function. But phishing, I heard mentioned someone else, to steal someone else's quote, business compromise email is an enterprise business. There's massive amounts of money in it. There's massive amounts of support infrastructure and organizations. The people who are phishing you and stealing money from your users who are clicking the links, it's not a bunch of script kiddies trying their luck. There's massive infrastructures, massive agencies and companies behind this, and there's billions of pounds worth of money. Okay? So I can turn that one on, and now those emails won't go into junk mail. This is a battle. This is not a simple thing. So to look at things like SPF and it having been around for 15 years and DKIM slightly less, and for you not to have done that in your organization, that shouldn't be something that 6 months from now you would say, I'm still in that place. Okay? The takeaway you have from this talk is to make sure that if you've got it in place, brilliant, well done. Keep it up to date. If you haven't put it in place, get yourself to a reject posture, a reject policy, as quick as you can. Use tools like this to see what's been blocked. Use tools like, let's pop up another one. Here's an organization that take the reporting. So in the DMARC policy, I had P equals reject, the policy equals reject. I also have a couple of email addresses. I can take all the failures of DMARC, so when an organization rejects an email because it fails DMARC, they can send analytic information to my reporter, my aggregate. And here's one aggregate company. There's a whole bunch of them around. Okay? This one's DMARCian, but there's Agri and there's others. This report is just, I've doctored the bottom corner so you can't see the domains of this particular company. But we see here that around about 5% of the emails that come from both of these domains, the red bar, around about 5% of the emails that are sent from both these domains in 7 days are suspicious, of which a chunk of those will be malicious. Okay. And so it's important to make sure that you get your SPF and your DKIM right. In this particular company's example, they've got DKIM enabled, so it says good under DKIM. One of the domains doesn't have a good SPF state. They have question mark all, which basically means here's the list of the senders, but anything else is valid as well. Okay. So that company would have a challenge to update that domain and try and get rid of that, try and make that red bar smaller. Okay. So there's tools, and I could drill into that and get a lot more information out of that as well. Okay. I've also got, coming soon, this is a different tenant, some additional mail flow information. Okay. If you went to the exchange stand this week on the expo floor, which is unfortunately now closed, but if you went there early in the week, they might have been demoing this to you. Okay. Some of this is useful stuff about mail flow, but from the specifics of phish and authentication, there's an SMTP auth clients report coming up. Okay. And what that will do is, because SMTP auth is basic authentication, it's a legacy authentication method, so it can't do MFA or hardware tokens or any of the nice goodness of protecting your organization. Okay? It's a potential hole into which users or malicious actors can try username and password pairs and try and get in and send email to you or from you using your infrastructure if the user has a weak password. So in this example report, it's saying that there were 10 emails that were authenticated. That expired really quickly. Let that refresh. It's that one. You have all these demos set up and hope they don't log out, and then by the time you finish talking and get to them, they've logged you out. Anyway, there we go. Right, there we go. So this report is showing me that a percentage of my authentication is coming from TLS. That's not what I'm interested there, but I'm interested in the SMTP auth client report in this example. And that's going to show me the number of emails that used SMTP auth. Okay? And I could view the details table in this example here and see who's sending email authenticated using an older protocol. And the example here, it's the CEO and the CFO and so on. They're probably phishing attempts and attacks. Okay? Maybe I've got a business function that is using these, but maybe more likely, probably I don't. Okay? So I'm going to have insights soon. They're going to let me see this sort of analytics. So Microsoft are able to see it because they've run the infrastructure. They're going to expose that to you as the customer. And so we can view information about that. And some of that might be legitimate. For example, that's probably the developers at the bottom. An application does it and they're allowed to use it, but maybe the CTO and the CEO and so on, that's an attempt to phish, an attempt to gain. In fact, they've already successfully gained their password and username. And so maybe you would go, got to change some passwords, got to implement MFA, got to protect my users some more. So they're the new insights and reports. So we've had a look at our anti-phishing policy demo. We've had a look at our new insights and reports. We saw reports from Microsoft. We saw reports from DMARC aggregators. And we have a call to action, which is to go and get yourself to a policy of reject within the next couple of hours. No, I didn't say that. Within the next weeks to months. Okay. But what are my other options to protect my users to finish? Okay. It's not just that I'm going to stop the phish coming in or that I'm going to protect my domain from being phished out there. It's a multi-layered approach to protection. I've got other ATP features like safe links and safe attachments. They're going to help me protect against insider phishing, especially the safe links. So someone works out the password of someone in the organization, logs in as that person and sends an email with a malicious link in it. ATP safe links is now rewriting links inside the organization as well as from outside. I've got tools like the attack simulator, where I can intentionally phish my organization. We did that. We got 20%, and we're an IT company. 20%, we're a small IT company, fairly small anyway. 20% of our users clicked the link, so we had a chat about link clicking. Okay. Multi-factor authentication, there's been lots of that this week. If you missed that, if you've done other things, and you can always watch these videos again. So another call to action is to come back and look at some of the security stuff that's been discussed this week. But multi-factor authentication, so that and make sure the user registers. So the user, if the account credentials are learnt, the malicious actor can't log in as that account because they need a second factor of authentication. They need the phone. They need the user to approve the login. Okay? And the user isn't logging in, therefore hopefully they're not going to approve the login. Okay? And risk-based levels of multi-factor authentication, rather than just turning it on for everybody all the time, turning it on when you need to in things like conditional access, which is my next point on there. So using conditional access to allow access to resources if, for example, allow access to resources if the machine is domain joined, or if the device is compliant, managed by Intune, etc. Okay. And there's things I can do there. MFA if the device is coming from a risky location. And risk might be the fact that I'm here now in Orlando, and in my case, in probably around about 20 hours, I'll be back in Oxford, where I live. But if I manage to log in Oxford before 20 hours, that's impossible travel. That may raise my profile of risk. And so someone logging in as me in my hometown, but not me, because I'm not there yet, that would cause a risk factor, and I would get an MFA prompt for that login, because I can't possibly be there that quickly, which is a shame. I would like to be there a lot quicker than it's going to take me to get home. Okay. The legacy auth example we talked about. So turning off legacy auth, but that can have impacts on older applications that we're still using. Okay. Stopping weak passwords, that's a much easier one to implement. The password protection policy. I have a blog post coming out on Practical 365 at some point on this, where we can take Microsoft's knowledge of common passwords, we can take it down to the domain, and we can stop people setting passwords that are common. So an obvious example will be password. For example, I set a password of password. That's a really bad idea. But in the Microsoft common password list, they see the passwords that are used as attacks against their system coming into Azure AD and into Microsoft Live. They know the common bad passwords that are being used. They know the passwords that are used at this point in time. So, for example, a couple of months ago, World Cup 2018 was probably a common password. Okay. Well, it'd be great if I could go into my domain and stop people, a few months ago, making a password of World Cup 2018. Okay. Well, that's what this technology lets me do. Okay. And it has about 500 passwords in the list, but it takes all variations of those passwords. So password will be blocked. Capital P at SSW0RD would be blocked. And it's not just blocked from the user picking that password. It's blocked from IT giving users those passwords. Oh, you've forgotten your password. I've just reset your account. Your password is password 1, says the IT department. Okay. That will help block that particular vector as well. And then moving to authenticators and hardware tokens, the removal of passwords completely. Moving to multi-factor, moving to a password-free environment. So they're the sort of things that we need to look at as additional to the phishing, because the phish will get in. Okay. There's massive amounts of engineering effort needing to go into stopping it. But as Microsoft implements stuff to stop it, the enterprise businesses that are running these phishing attacks, they will go to trying something new. It's a battle. It's always changing. It's always moving. Okay? And so these are things you need to do now. Come back next year, and I'll probably talk about something else on this, and we'll have other things to do. Okay? But that's my session. I hope it's given you some things to think about. Please do fill in the evaluation. And I have 3 seconds left. I've done that very well, haven't I? Red. Thank you very much.